15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on Space Nuts. It's all about astronomy, space science, and whatever else we can cram in. And this is our Christmas edition. So Merry Christmas to you, and I hope you're having a good time avoiding traffic and the mayhem of shopping between now and then. Well, then might be today, because this does get broadcast on the Community Radio Network in Australia on Christmas Day. So whatever the situation, I hope you're well. Now, today on the program, we will be talking about a new theory involving dark matter. An idea has been posed that could answer the question as to what dark matter is, but there are people, one of them that I'm about to talk to, who's not so sure about that. Also, the launch of the James Webb Telescope. It's happening very, very soon. WoodSat. I love this story. WoodSat is exactly what it sounds like. We'll get to that. And because it's Christmas, we're going to talk about the Christmas star, which Fred and I have done before, but not for a very long time. And questions about radio circles and space ethics coming up as well. I'm your host, Andrew Dunkley, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you today?
I am well. I think we're past the Christmas rush at our place, but not everyone gets as organised as my good wife, so good luck to them. But really good. What about you?
Very well, thank you. Yeah, Christmas has not been organised here. We have a Christmas tree. We discussed all kinds of things. The big event will be on Christmas Eve, when Marnie's family turns up for a Christmas meal, which we're looking forward to very much.
That'll be lovely.
We'll all be
we're looking forward to
masks,
seeing the grandchildren and having the house destroyed as they get into it. So that'll be a lot of fun. All right, let's get down to business. And the James Webb Telescope, everybody's waiting with bated breath as the launch gets ever closer, and we're looking at any time soon, basically.
Christmas Eve, certainly our time, Christmas Eve, it will be. This is in Australian time. It's I think it's 1 o'clock in the afternoon. We're in pole position for it. It launches after midnight Universal Time. So yes, we're very much looking forward to that. To me, the event that has been in the offing for probably best part of 25 years, in fact, since the James Webb Space Telescope was first proposed. 6.5 meter diameter mirror, an infrared telescope. Hopefully we'll, hopefully we'll get rid of the frog in my throat this morning. But also, as an incidental, it will probe the universe back to within maybe a billion years of its birth, perhaps discovering the first stars and galaxies. And also, at the other end of the scale, it will have the attribute of being able to analyze it in unprecedented detail, the atmospheres of extrasolar planets.
Yes.
So, we might find all kinds of things turning up there.
Very exciting. And I've seen a lot of comment about it on social media. A lot of people are really excited by this project.
Yep.
And of course, those that are at the coalface who've been making it happen, this is crunch time. So I'm pretty sure there are a lot of nerves building up to this because you only get one shot at it.
Yeah, you do. That's right. Given that it's a very ambitious project to sort of unfurl this 18-element mirror and make it all look like a single optical surface, that's extraordinary engineering on its own. To do that on Earth is pretty spectacular. To do it 1.5 million kilometres from Earth, that's another question altogether. But that's where it's going. It will be out there.
In one of the Lagrange points.
L2, that's right.
L2, yeah.
L2
and unlike Hubble, which did run into some teething problems when it was first launched, they were able to go and fix it. This one, not so simple.
It's not so simple. It's impossible.
Yeah.
With our current technology. Yeah, it's too far away.
Let's not think about that. Let's just
not think about that. No.
Wish them well. Godspeed to the James Webb Telescope team. Let's now look at this theory about the possible reason for dark matter. Even though we don't know what it is, a theory has. This is actually an old theory, but they've revived the possibility that it is the answer to this question. We only said last week that we hoped that someone would come up with the answer, and within a week, as often happens in journalism, somebody's proposed a potential answer. You're not overly convinced by the sound of it.
No, it's let's just outline what this is all about.
Yes.
It is the idea that the universe is filled with what are called primordial black holes, and these are usually small, although some people have postulated there might be huge ones as well. In fact, we talked about those a few weeks ago. I forgot what they were called. Humongous primordial black holes or something. They had an acronym for it. But the idea is that in the early universe, the density of the hydrogen gas was so high that what you could get would be clouds of gas, Andrew, that would collapse under their own gravity. Now, normally that's the first stage of star formation. So a cloud of gas collapses under its own gravity and forms a star. And that's how stars are born. But in the early universe, the suggestion proposed actually by Stephen Hawking as long ago as 1971, so a 50-year-old theory this is, the idea is that the density is so high that the collapse doesn't stop. In other words, it doesn't need to go through the star formation process. The cloud of gas collapses and simply keeps on collapsing until it forms a black hole. And that's the idea of a primordial black hole. And Hawking's speculation was that the universe was full of, possibly, but was full of these, generally speaking, relatively small ones. And that a lot of those are still around because, as you and I have spoken about before, black holes do evaporate, but they evaporate in times much on timescales much longer than the age of the universe currently. So they haven't had time to disappear. Some might have done, but most will still be there. So back in about 1980, somebody suggested that maybe these black holes are actually what we see as dark matter. So this is a pretty old idea. It would have been early 1980s. And the thing about this is you can actually test it by looking for evidence of gravitational lensing in star fields. So what you do is you look at a region of sky which has lots of stars in it, and you measure their brightness over time. And what you look for is the increase in brightness that you would get from a black hole passing in front of one of these stars. Because what it does, the black hole acts as a gravitational lens, it magnifies the light of the star, and the star brightens up. And this sort of study was carried out during it's probably actually the 1990s rather than the 1980s. Now I come to think about it, because we were involved in it here in Australia. It was one of the jobs that was done by what used to be the Great Melbourne Telescope, a telescope very close to my heart, which is being restored down in Melbourne, built in 1869. They make a big fuss of me down there because I'm one of the few people still alive who worked for the company that built it. It's
I thought you were going to say you were there when they built it.
That was the next best thing to being there. I knew I knew people who were there in 1869. Anyway, the Great Melbourne Telescope was refurbished in the 1940s, actually, and then refurbished again in the 1970s, I think, and used in the 1990s to observe rich star fields, looking for exactly this, the kind of gravitational lensing effect that you would get from primordial black holes. And they didn't see it. And that is one reason why the idea of black holes, of dark matter being machos, and these primordial black holes count as machos. What are machos? Massive compact halo objects. And a massive compact object is a black hole. So that was what essentially removed the idea of dark matter being machos from the agenda. And it's still regarded as pretty seminal work that, it wasn't done just by the Australian astronomers, it was done in other observatories as well. There was no evidence that primordial black holes made up the dark matter. And that, I think, is still the case. The work that has now been done and what we're talking about today comes, I think, from Miami, University of Miami.
There are three organisations that I've come across that are involved in this: the University of Miami, Yale, and the European Space Agency.
ESA, that's right, the European Space Agency. And there's, so that they have put forward a new model, and what it does is, I think the new model actually revisits the timeline of the early universe. So what they're trying to explain, as well as the dark matter, is the origin of supermassive black holes at the centers of galaxies. How did they get so big so quickly? That's the bottom line there. And so what they're perhaps speculating is that these primordial black holes could actually merge very quickly to grow into, well, either objects that might contribute to the dark matter or objects that would form supermassive black holes. Now, I don't want to make it look as though I'm poo-pooing this idea, Andrew, because I'm not. I think it's a very interesting idea, and it would be fabulous if we could show why it is that these things weren't picked up when surveys were done to detect them, the machos, the supermassive, the primordial black holes. So it is a really interesting theory, which I think it's worth it's worth pursuing. It's certainly worth looking at, as are all theories, including MOND, the modified Newtonian dynamics, which our friend Peter Verweyen is a great advocate for, doing his PhD on it. So I'll look at this with great interest and follow. I mean, what's going to be the verdict is the way the astronomical community responds to this, whether it is seen as an absolutely monumental breakthrough. You need to be able to test it. That's the point.
Yes, and that's important. I mean, you can come up with a theory, but if you can't test it, you can't prove anything. So it forever remains a theory. Yeah.
So one of the things that might be useful in testing it is this marvelous telescope we've just been talking about, the James Webb Space Telescope, because they are looking, or the telescope will look into the distant past, as I said, probably exploring the first billion years of the history of the universe, maybe seeing the first stars form and things like that. And that actually is likely to put limits on what these black holes could be like. So the James Webb might very well contribute to this argument and might very well give us some insights into whether this could be the answer to the dark matter problem. It would be marvellous if it was.
Wouldn't it be?
But we don't know yet. But so it's a big step, and it's a great way to wind up 2021 to talk about.
Yes, indeed.
Something like
especially
this.
When we were only talking a week ago about when are they going to come up with an answer. Well, they haven't, but they are starting to reconsider an old theory. Now, they all agree, these universities and ESA, that the original theory didn't hold much water.
Yes.
But they're suggesting modifications that might validate the theory, according to what I've read. So, I don't know what those modifications might be. I haven't read that deeply into it, but let's just watch this space, as we tend to say, and see what they come up with. We might know something reasonably soon. Speaking of which, when do they think the James Webb Telescope will actually be online and active?
If I remember rightly, we had this from a listener question a little while ago, and if I remember rightly, the answer is about a month. I think it takes about a month to get to its station, to get to F2. It's quite a long way, 1.5 million kilometres. When you think it's, I think it's, is it 3.9 times the distance to the moon? That's about right.
Yeah.
So it's a good trek.
Yes, indeed. All right. Lots of interesting things to look forward to. Next year we certainly will be reporting on some of the wonderful things that the James Webb Telescope might discover. This is Space Nuts. You're with Andrew Dunkley and Professor Fred Watson. Let's take a quick break from the show to tell you about our sponsor, NordVPN. Now, why do you need a virtual private network? Well, it gives you security. It gives you peace of mind. There is no geo-blocking. There's a 30-day money-back guarantee on this particular offer. You can block hackers, you can block spammers, you can block criminals, you can protect your activities and your online banking, and you will be secure when using a public Wi-Fi service. And it works on any platform, Windows, MacBook, mobile phones, tablets, you name it. NordVPN works, and it works fast. It's very efficient and highly rated. Now, as a Space Nuts listener, you get a special deal, 2 years for $3.16 a month. And I'll remind you that on the Australian browsers, the prices show up in US dollars. So bear that in mind. But that's $79 for 25 months, saving you 73% on the regular price. Lots of good reasons to get NordVPN, and it's as simple as logging on to this special URL, nordvpn.com/spacenuts. That's nordvpn.com/spacenuts. And of course, they'll throw in a 30-day money-back guarantee. They are so confident about their product. Seriously fast internet service and premium security from NordVPN. The URL again is nordvpn.com/spacenuts. Check it out today and grab the deal. And now back to the show.
We're here also.
Space Nuts.
As I've mentioned, maybe just once or twice in the last calendar year, if you would like to become a patron and help support Space Nuts financially, just go to our website and there's a supporter tab there. And just check out what the options are. You can become a patron and pay a little bit per month through Patreon or Supercast, or you can just do a one-off through a donation in PayPal, or you can click the Buy Us a Cup of Coffee button. Now, these are all options. It's not essential. We are not demanding that you do it by any means. We're just suggesting that the idea is available to you. If you want to support Space Nuts, you can certainly find out more through our website, spacenutspodcast.com or spacenuts.io, and see what it's all about. And if it's not for you, it's not for you. But 30-day trials available on Patreon and Supercast. So if you don't like it after 30 days, you can go, nah, not for me, and carry on. But if you do become a patron, there are presents. We'll send you presents. The longer you're with us, the bigger and better the presents. So, we call that a carrot. The carrot and the stick. It's the old-fashioned way of getting the horse to move. Not that I'm referring to anybody as a horse, although they are elegant creatures. Now, let's get out of that hole and put ourselves into the next one. I love this story, Fred. I'm so excited by this. This is expected to be launched next year, probably not with the same amount of fanfare as the James Webb Telescope. This is a new satellite. It's a test satellite. It's called WoodSat because it's going to be made of plywood. I think this is awesome.
It is indeed. This is a great story, and it's exactly as you've said. The mission is to see whether you can make a satellite out of wood, because that's a good material with some good properties. Compared with the space grade titanium and things like that are normally used. So it's a CubeSat, which is 10 by 10 by 10 centimeters, kilograms worth of kit inside. That's the standard standard CubeSat model. Excuse me, I've got the CubeSat in my throat again. But what they're doing is making it out of wood, because they want to see whether that's a possibility. And if you could fly wooden satellites routinely, it would have all kinds of advantages. Wood's a lightweight material. It's easy to shape and deal with, much cheaper than space grade titanium. Cheaper. Burns up without any problem when it re-enters the atmosphere.
Exactly.
So and this is the brainchild of a company called Arctic Astronautics up there in Finland, and they do manufacture CubeSats. That's their main stock in trade. But this is a one made out of wood. It's a plywood. It's a coated plywood for the basically for the outer surfaces and the inner surfaces as well, because they're all at sort of open to space. It's a birch material. That's the same material as is used for hard wood furniture and things of that sort. I'm hesitating to mention the name of the company, but you all know who I'm talking about. Not a Finnish company, but a Swedish one. So it's that stuff. It's ordinary. It's basically ordinary plywood, except that they have treated it because ordinary wood would be. It's got too much moisture in it, and it's got to be utterly dry to be in space, because the moisture in wood would essentially evaporate. In fact, it turns directly into gas, and will probably distort the wood beyond recognition. It would not be a pretty sight.
No.
So what they do is they dry it out to start with, and then they are actually coating it with very thin layers of things like, well, aluminium oxide. That's one of the coatings that is being put on top of it, and the idea is that presents sort of will seal the wood and prevent outgassing, which is the problem. If outgassing is something that you've got to deal with. All space engineers, you talk about outgassing, and they just don't want to know. It's taking them down territory that you'd rather avoid. So it's got this coating of aluminium oxide, but they are also hoping that will prevent corrosion of the wood surface by atomic oxygen, which we don't normally. Well, we don't encounter it at the surface of the Earth. It's right on the edge of the atmosphere. It's basically single atoms of oxygen. And it is quite corrosive. As I said, it's likely that it will darken these plywood panels. That's one of the effects of it. However, the engineers think that the wooden satellite should survive. And so what they're doing as well, since this is a test, what they've got is a couple of cameras which are looking at different surfaces on the outside of the spacecraft, the CubeSat, which have been treated in different ways. So there's varnishes and things like that have been put on, I'm sure, in over small areas, and then a camera to see what actually these things turn into when they're subject to the environment of space. I think they've got some other experiments on board to look at 3D printed plastic material to test whether that stuff works as well. So lots and lots of things going on, and it I think it's a brilliant experiment. And who would have thought it? A wooden satellite going into space.
Yeah, wouldn't you know?
Yeah. Wouldn't you know? Thank you.
Yeah, it is. It was due to be launched in November, but they've pushed it back to next year. So it'll be early next year that we're likely to see the launch of WoodSat. I love the name of it, WoodSat. It's just a perfect name, and what a great idea! I mean, if this works, this could make satellite delivery a whole, change the ball game completely.
It could do. Yes, that's right.
I can see the movie now. Borers in space. It's just won't be long.
Yeah, from Woodstock to Woodsat. There you go.
That's pretty even better.
Groovy, man.
I love it. Yes, very, very groovy.
Yeah.
Yes. Well, we'll just keep an eye on this one, because I'd love to just see how it all goes. And again, we wish them well. I love some of these experiments that have been popping up in recent times. Of course, the different attempts to try and recover space junk. We talked about that experiment with nets and harpoons and all that sort of thing. Now we've got wooden satellites being tested. I mean, gosh, it's just what a lot of fun. If I could have my time over again, I might change careers. I think this would be just so much fun to try and get involved with. And, if they succeed, all power to them. That's fantastic.
Yeah. I mean, that's the root of all science, really, is that it's just having fun. And
of course, yeah.
The trouble is, one day somebody important is going to find out that we scientists are having a lot of fun.
You're just getting paid to turn up and enjoy yourselves.
Well,
what's that all about?
Yes. Yeah, what's that all about? That's right.
Now, being Christmas, Fred, I thought we'd revive a story that you and I did some time ago, and it is the Christmas star, because a lot of people do wonder what happened that night and what it may have been. It was actually something that was studied, and an answer was proposed.
Well, yes, there have been many. People have been looking at the Star of Bethlehem as a possible scientific observation for 400 years. Kepler was one of the first people to think about this. Johannes Kepler. So what's the story? Well, the Gospel of Matthew mentions this star, which wasn't just there for one night. It apparently was visible for some time, and which was subtle, though, because Herod, who was the bad guy in all this, he wanted to get rid of this new king of the Jews. He asked the wise men, the Magi, who basically were Persian astrologers probably, who'd kind of seen something in the sky. He asked them to show him where the star was, which kind of rules out something really obvious, like a supernova or a comet, something that would be brilliant in the sky. If he had to ask them, his own astrologers would have been advising him of what was going on in the sky. So it's thought to be something much more subtle. I might just mention as well that a lot of people at the moment, they see, because Venus is brilliant in our evening skies at the moment, not for much longer actually. It's going between the Earth and the Sun towards the end of at the end of this month. But it's brilliant in the evening sky, and people say, well, could that have been the Star of Bethlehem? But that happens every couple of years or so. It's and these guys would have fully understood all that sort of thing. So that would not have been anything new or spectacular, whereas a comet or an exploding star would have been, although, as I've said, that's kind of ruled out by the fact that Herod had to ask them where it was. So the thinking has been for many years that it is probably something a lot more subtle, and there are significant conjunctions of different planets at around this time in constellations that have got significance to the Jewish people and things of this sort. I think one in Leo, the constellation, which is, of course, speaks of kingship. It's that sort of thing. There were several of these conjunctions. They're all about the right time, around 6 BC, and more, I think, in about 3 BC. The dating of all this is a little bit fluid, but I think the dating of Herod's death is fairly well established, and I think that was before 0 BC. So the events reported in Matthew's Gospel must have happened before his death, since he was still around to do all the bad stuff. So those are the kinds of things that people imagine the Star of Bethlehem might have been, some sort of subtle conjunction.
Okay, so maybe a planetary alignment, or but not likely a comet. Comet Leonard.
Well, Comet Leonard, that's right, which I haven't managed to see yet because we've had such cloudy weather.
But one of our listeners actually got a photo of it.
Oh, very good. That's good. Yeah. Great to hear. The thing about comets, Andrew, is people have speculated that perhaps it could have been a comet, but comets have been since ancient times bad omens. And this was exactly the opposite. It's
except for Herod.
Well, it was a bad omen for Herod. That's right.
So, we're thinking a conjunction. It may have been that consequently became known as the Star of Bethlehem. You are listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
3, 2, 1.
Space Nuts.
Now, have you visited the Space Nuts shop yet? You can't walk into it, maybe one day, but at the moment it's a virtual shop on our website, spacenutspodcast.com, and just click on the link that says shop, which, that that's quite an astounding coincidence that we have a shop on a tab named Shop. But in there, you can get the bubble-free stickers. You can get the T-shirts. You can get the polo shirts. Look, if you're watching on YouTube with the logo on them, you can get cups and mugs like that one behind me, or the tote bag. There are hats and caps and hoodies. Those are for the tough people in our Space Nuts podcast group, and all sorts of other things. And the idea that was posed by young Ashley, I am a Space Nuts sticker, they are available too. I am a Space Nut. So yes, and we sent some of those to Ashley as a thank you. So fabulous. If you want to visit the Space Nuts shop, it's on our website. Now, Fred, we got some questions, and the man who suggested you switch to A2 milk, Peter on the Gold Coast, has actually got a question for us this time. So let's see what he wants to know.
Hello, Fred and Andrew. It's Peter, the milkman from the Gold Coast here. I have a question this time, not a suggestion. I was listening to your podcast 282, the latest one, and you mentioned radio circles, which I had never heard of before. And I was just wondering, is it possible that they could be Einstein rings actually appearing in the radio frequency, and where you can see a galaxy in the center, then that galaxy could be doing the lensing, and where you can't see a galaxy, that there might in fact be a supermassive black hole in the center, and it could be doing the lensing? That's it. Simple question. Interesting subject. Stay well. Bye.
You too, Peter, and Merry Christmas to you. And we talked about radio circles last week, and the mystery of some of them that have galaxies inside them, some don't. What do you think of his theory?
I like Peter's thinking very much, because it links two things that are reasonably circularly symmetric, but it has been considered by the team who discovered the odd radio circles. Einstein rings were one of the things that they ruled out. Just to tie up the loose end, what are Einstein rings? If you have two objects in space, one in front of the other, which has got a very nice spherical, symmetrical gravity field, and that would certainly be something like a black hole, but more often than not, it's a galaxy. A massive galaxy, and then behind it, in exactly the same line, behind it, a more distant object. What the galaxy can do is, because of its gravitational lensing, the fact that it bends the space around it, and that forms effectively a lens, you get this ring of the further object. You don't see it as an image of its. Well, you see it as an image of itself, but it's distorted into a ring that surrounds the lensing object. They are well known, Einstein rings. There are several really good examples of them, and they're not just in visible light; they're in radio emissions as well. I think the reason why they were ruled out by the team who've discovered the odd radio circles, the radio astronomers, is because they're too far away from, for example, the lensing galaxy. If that, as Peter says, some of them have got galaxies at their center, but if that was forming an Einstein ring, the ring would be much smaller than the odd radio circle. And I have to say that, the images I've looked at of odd radio circles, they don't look anything like Einstein rings, which have got really quite a distinct structure to them. You can usually see traces of the structure of whatever it is that's being magnified and turned into a ring. You can usually see remnants of that in them, and these odd radio circles, they don't show that kind of thing. They don't have the same sort of sharp edges to them that the Einstein rings do. So it's a great suggestion, but certainly the team who have done the work on odd radio circles, who are much more knowledgeable than I am about this topic, they've ruled them out. So, in fact, they've ruled out everything. So they're saying some unknown process, some phenomenon that causes these things that is not yet understood.
And they haven't found many of them yet, have they?
No, how many did we say when we were speaking last week? Was it 9? I think it was something of that sort.
Something like that.
Yeah, yeah.
So, yet another mystery for us to ponder, I suppose, Peter. And lovely to hear from you. Let's move to Pennsylvania, where we're going to discuss. Well, Misty will explain what she wants to know.
Hi, Andrew and Professor Fred. This is Misty West from Western Pennsylvania in the United States. I'm curious to know about the ethics of space exploration and who talks about it. Like, do we have a review panel or an international body that discusses the direct ethical concerns about space exploration and how we are good space stewards going forward? I mean, we talk a lot about like trash in space and the preventing the Kessler syndrome. I've heard a few news stories about concerns for contamination with microbes from Earth going to other worlds, or with bringing things back from other worlds to Earth that could potentially impact humanity. And then, like, if space explorers going forward are taking a one-way trip basically to space, like, who talks about that and who makes those decisions? So the other question along those lines I had was, if there was a large asteroid that we discovered today, say it was coming from the sun and we couldn't see it until the last minute, and it was large enough that we knew it was going to destroy life on Earth, who would make the decision to tell people, and would they tell people? Would you tell people if you saw it and you knew about it? Or just let, people be surprised at the last minute? Okay, thanks, guys. Love your show. Really appreciate it.
Thanks, Misty. And thanks for being a patron, by the way. I hope you enjoy the little prezzies we send out to you. Some really interesting questions there. The latter question probably putting you on the spot as an astronomer, Fred. But, who does review the ethics of things we do in space? And my first thought was the Astronomical Union, International Astronomical Union, although they probably are more focused on some of the rules and regulations that apply. So is there any particular body or bodies that is focused on these things?
Yeah, there are a number. And I'm really glad Misty's raised this, because this is a question, it's a topic that interests me a lot, and I've had a little bit to do with. I mean, just to mention what that is, we have a public science institution in Australia called Questacon. And yes. Questacon runs fabulous exhibitions. They've got exhibitions at their headquarters, which are in Canberra, so there's a science centre there. But they also have an exhibition. They sometimes have travelling exhibitions, but they've also got something down at the Space Agency in Adelaide. They've got a space research centre there. And as part of that, and this is the bit I was involved with, they have set up what they call an ethics kiosk. And this is inviting the public to give their opinions on questions exactly like the sorts of things that Misty's asked. And it's really interesting, because often those questions don't have a straight answer. There's arguments both ways. And I'm peripherally involved. I'm certainly not directly involved with it yet, but there might be, I hope to be, with a study of the analysis of the responses from the public, members of the public who've tackled those questions, because they're quite interesting. I've seen some of the results, and they're not entirely what you would have expected, what people think about exactly these sorts of issues. So is there an overarching ethical body? In a sense, there is. COSPAR is the Committee for Space Research. It's an international body. It's the signatories of the Space Treaty, which was signed back in 1967. I can't remember. I think it's 114 countries that are signatories, and there are more that are sort of observers or something of that sort. I can't remember the details. I was looking at this not very long ago. But anyway, COSPAR is a body that does look at exactly the issues that we've just mentioned. And in particular, and perhaps the best controlled one, is the one that Misty mentioned in connection with microbes, because COSPAR, very early on in the piece, in fact, they may have set this up in the 50s, some of this sort of stuff, set out what are called the planetary protection rules, which are all about avoiding microbial contamination, either forward contamination by earthly microbes going to somewhere like Mars that could actually sustain microbes, or back contamination, which is the other way around, when you bring stuff back,
Yes.
contaminate the Earth. Excuse me, Peter, I'm taking your advice regarding milk, but it doesn't always work. So that works well. The planetary protection rules are pretty well adhered to by those nations who are sending, for example, rovers to Mars. The rules are followed. The space vehicles are sterilized to a very high degree of sterilization, certainly in the case of ones that visit places where life could take hold, perhaps. The regions of Mars where occasionally it gets above freezing point, for example. So that's, I think, something that's reasonably well looked after. NASA has a planetary protection officer. I'm sure other space agencies do as well, which follow the rules. But it's a bit more fluid when it comes to simply launching satellites.
That's become an ethical question this year, with so many, tens of thousands of low-level satellites being launched for internet purposes, and I know that's been a talking point amongst our audience, because a lot of them are amateur astronomers, and they're really concerned about the light pollution or the interruption it might cause to their observations.
Indeed, and that's my involvement as well, because we're very heavily involved in this in the department that I work for. So it's and in fact, we had a very nice presentation a couple of weeks ago by a person she's actually a space lawyer, but also a space ethicist. And I'm hoping to set up a Zoom talk from Cassandra Steer. She's at the Australian National University. So that's something we might advertise down the track on Space Nuts, because she's across this topic completely. But my understanding, and a lot of this comes from Cassandra's presentations, is that the global body in connection with this is something called the ITU, the International Telecommunications Union. And they're the ones who allocate the parts of the radio frequency spectrum that these satellites will use. And they are, it's not rubber stamping that they do, but they're pretty keen to promote the space industry, promote communications and things of that sort. So they do they do treat these things seriously, and they tend to give the tick to anything that's reasonable. The jury's still out on whether they'll give the tick to an application from the Rwandan government recently for 2 space constellations, which would total 327,000 satellites.
Wow.
And the feeling in the industry is that they're just probing to see what would happen, but the ITU could give that a tick. But that's the global level. But the real regulation is at national level. It all takes place in the national levels, and that is, one of the inadequacies. You really need a global body, and there is one. There's something called COPUOS, the Committee for the Peaceful Uses of Outer Space, which nations actually subscribe to. They send national representatives to COPUOS. We do here in Australia, members of the Space Agency, but that's a UN body. It's certainly not the IAU, the International Astronomical Union. They can certainly feed their views into COPUOS, but they don't dictate things. But COPUOS is being a UN body. It's not very nimble on its feet, if I can put it that way. Things take a long time to work out, whereas the National Space Agency, or the national agencies that validate spaceflight, they can work much more quickly. And in the US, there's actually quite a lot. There's the FAA, the Federal Aviation Authority. There's the FCC, I think, which is the Federal Communications Commission, and then there's NASA. There's various levels of approval that have to be sought by bodies wanting to launch satellites, like SpaceX with Starlink, but the tendency is for them to get the tick of approval. Now, just going to the extreme edge of this. Sorry, I've rambled on. You can tell
No, that's okay. It's really fascinating.
Misty mentioned the issue of people or agencies authorizing a one-way trip into space for humans. And my guess is that would not happen, that I don't think there's any space agency in the world, with the possible exception of some, sort of basket case nations who I won't mention, that might. But I think I don't want to cause a diplomatic incident there, which is why I'm not mentioning any names. The spacefaring nations of the world, I think, would draw the line at that. I don't believe they would authorize the launch of humans into space.
Until the day comes where they want to export their convicts. I mean, that's how Australia came about.
That's right. I mean, we in Britain are number one criminals in that regard. Not me personally, but my forebears, I know.
Yes, but as Australians, we love to rub it back in the British faces because we beat them at cricket every time, and they caused that. Yeah, we're giving them a bit of a towel up at the present time. Yeah. But these ethics questions, as I heard you mention, that they are often administered at a national level. We've seen that kind of go down the toilet recently with a certain missile launched to destroy a satellite. I mean, how unethical does that appear to be?
Yeah, that was surprising. I have to say, that was surprising.
Yeah, well, I suppose if we're going to do a top 10 dumb things in space list for 2021, that'd be at the top.
It will be on it, that's right.
Indeed.
Sorry, go ahead, Andrew. No, go ahead.
No, I was going to go to the next phase of Misty's question, but if you had one more thing to say about
it. Just that it is really complex. It's something I've struggled to understand, and I've had my toes in the space industry for 50 years. But just the legislative framework and the ethical frameworks of it all, it's really complicated. But I do believe that people are more and more people are asking exactly the questions that Misty's asking. What are the ethics of all this? I've talked long and boringly probably about the ethics of colonizing Mars, because I think it's an entirely unethical thing to do. But there's nothing to stop it. If SpaceX and Elon Musk wanted to do that, at the moment, there's no legislation that would say you can't do that.
Yeah, okay. Yeah, I think these kinds of debates are going to go on for decades to come. To Misty's second question, and that of the ethics of warning people of impending danger. So she kind of put you on the spot. Yeah. If you were to go out tonight and look at your telescope and say, oh, look, not so little asteroid, and do your calculations, which will hit us in 2 weeks' time and destroy the planet or cause widespread damage, would you tell anyone if there was nothing we could do about it?
Well, there would be stuff that could be done. There would be civil defence measures that could be done, some of which might be very extreme. First of all, it's good to recognise the point that something big enough to do to have global extinction consequences would be big enough to spot. And the likelihood is that it's not going to creep up on us unawares. There might be an object of that size that we'd get 30 years warning about, and then that might be something that we could take defensive measures.
So the ones that either are very close at the last second or have already passed us are smaller ones that have come in from behind the sun that we just didn't spot.
That's right. And we're talking, something 50 meters across, which could certainly wipe out a city. That's at the level which makes it hard to detect. Actually, 50 meters is probably too small, but you'd get similar effects to what we had with Chelyabinsk in 2013, which effectively, it didn't wipe out the city, but it did a lot of damage and injured a lot of people. There were no fatalities, but there were injuries. So something 100 meters across would be more significant. That's a 1 in 50,000 year event, I think, remembering, the statistics. So this whole field is relatively well understood, and there are lots of instruments in the world which are actually looking for these objects. And the big new one, which is going to come online, is the Vera Rubin telescope down in Chile, an 8.4 meter, I think it is, telescope, which will survey the entire sky more or less every week. So you're going to find objects down to this 50 or 100 meter level. NASA many years ago Congress mandated NASA, I think in the 90s, to explore this type of object. And NASA, so I can't remember when it was probably 10, 15 years ago, they satisfied all the authorities that they had discovered 95% of all objects bigger than a kilometre in diameter. Now, there's still 5% that you're not going to find, and that's because this thing is all done on statistics. But most of those big ones, these are kilometre-sized objects, which would cause statewide damage, not global, but statewide. That is probably we hope, something that's not going to take us unawares. And it's the smaller objects that they're now concentrating on. So the answer is,
would you tell?
But I wouldn't. I would not know. I wouldn't be the first person to know. There are global bodies that look after the idea of potentially hazardous asteroids. They would have a set of protocols, I'm sure, on how the public was informed. But I don't think any secrets would be kept. This is a scientific as well as a civil defence exercise. I think things will be pretty open because it's a global thing. You're not able to keep secrets. There are many amateur astronomers now that could monitor the progress of a 1 kilometre asteroid if it was on its way to Earth and work out its orbit and tell you when it's going to happen.
There you go. You can sleep tonight, Misty, knowing that it's covered. There are a few that slip under the radar, but they're not the earth-shattering ones that you see in the movies. Yeah. Indeed. Thanks, Misty. Lovely to hear from you. Fred, that wraps it up for another episode. And I just want to say thank you to you for everything you do on Space Nuts. You commit a lot of time and effort to it, and it is greatly appreciated by me, by Hugh, but by the wider audience. We get so much positive feedback about what you do, and it is such a joy to work with you. So thank you very much.
Thanks, Andrew. Likewise with you as well. It's great to have a couple of old blokes who can talk about stuff like this and people want to listen.
Yes, I think it's fantastic. And I love that we've created this little community.
A little family, that's right.
And they can talk to each other and show each other their photos and get on Facebook and do that via the Space Nuts podcast group. So, I think it's terrific. And thank you to our audience. Thank you to all of you for just being a part of this little thing that we created a few years ago that's grown to become what it is, and hopefully will go even bigger and better next year. Without your support, we would never have got here. So thank you so much, and we wish you well for Christmas and the new year, and hope you have, to use the American vernacular, happy holidays. And we look forward to talking to you again in 2022. Thank you, Fred, and have a Merry Christmas.
You too, Andrew. Great festive season.
Fred Watson, astronomer at large, part of the team here at Space Nuts. Thanks also to Hugh back in the studio, who does it all. He just puts it all together and gets it out there, does all the legwork. We have the fun. He just has to do the hard work, and we really appreciate it. And thanks to our sponsors. So many people have come on board in the last 12 months or so to work with us, and we appreciate them as well. But from me, thank you so much once again, and we wish you and your family all the very best for Christmas and the new year, and we'll catch you on the next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.